One of the concerns that people have about the accumulation of plastics and microplastics in the environment is how that many of these materials tend to be nonpolar in nature and could potentially act as locations for nonpolar pollutants to accumulate. To demonstrate this, what we have is a polystyrene foam packing peanut that we have colored with a permanent marker. And the permanent marker here represents a nonpolar pollutant. And if I take this polystyrene packing peanut and put it into water, you can see that the marker stays on the surface of the polystyrene. You say, well, is this really a big deal then? Because the pollutant would stay on the polymer, in the polymer, and is that such a bad thing? At least it's not getting into the water. But if I move this over to a bit of 2-propanol in water solution to a less polar environment, and animals have a mixture of polar and non-polar regions in their body, you can see that this ink will leave the polystyrene packing peanut and get into the 2-propanol solution. And you can imagine that potentially microplastics getting into an animal, and that happens, and nonpolar pollutants leaving the microplastics and getting into relatively nonpolar areas inside the animal where they could potentially do harm. Okay, now one of the approaches to possibly circumvent this would be to use plastics that are much safer for the environment, polymers that are much safer for the environment. So what I have here is a starch-based packing peanut, not polystyrene-based packing peanut like we have here. And starch-based packing peanut is water-soluble. So if it comes into contact with water, what will happen is the starch is easily broken down. Okay, and if there are pollutants that get onto the starch from the environment, they won't, if the starch breaks down, the pollutants will not even make it over into an animal in the first place. And so the pollutants would potentially not have the opportunity to make it into locations where they could do the most harm.